And, then we have to find the value of t when v equals 1,000. So in order to solve this differential equation, what we have to do is we have to integrate both sides with respect to t. I want to find v. I've got to integrate this with respect to t. So I'll have the integral of dv, dt, dt. Okay, so that will leave me with dv here, right? The integral of dv is equal to now if I integrate this side with respect to t, I must do the same to this side. So you have 30 minus 0.01 and, 0.01v. That has to also be integrated with respect to t. Okay, now this is where a lot of students start messing up. So that here you end up with dv, integral of dv. Now we have to separate the variables. Now this, you can't separate this like as these two are separate things. It has to be like a whole thing, because the whole of this is integrated with respect to t. All right? It's not like I can add 30 to both sides and, or I can add 0.01v to both sides. I have to take this as all of this times dt, you could say, right? So when I want to separate the variables for something like this, I have to divide both sides by the whole of this. So I'm going to have the integral of, I'll have 1 over 30 minus 0.01v dv equals, and here I'll have the integral of, basically be left with 1 dt, all right? So now we want to find what v is in terms of t, okay? And there's different ways we can proceed here. What I really like to do here is I like to use a method where I don't have to put plus c. I don't have to find a constant of integration. I can find it kind of almost automatically, all right? So the question says, solve the differential equation and find the value of t when v equals 100. Now, if it just said, find the value of t when v equals 100, then I would do something slightly different here. But because it says solve the differential equation, means they want something specifically v equals some function of t. So that's what I'm going to do. I'm going to find what v is, okay, in terms of t. And I know when v is 0, t is also 0. So I'll put those boundary conditions here, and that will help me find c automatically. Some people, they will integrate it as an indefinite integral, and then they will substitute v equals 0 and t equals 0, and then they will get their, then they'll get the value of c. They'll have to find what c is, and so on. But this will find the value of c kind of automatically almost. So I like to do it this way. So now what I'm going to do is I'm going to integrate both sides with respect to what they're supposed to. This side is integrating this with respect to v. So this is something where if I differentiate the denominator, it will give me a constant. I'll get minus 0.01. All right. The numerator is also a constant. So this can be used. You can use reversing of the chain rule to integrate this. You have ln, and whenever you use ln, you have to always put modulus of 30 minus 0.01 v. Okay. And then I have to divide this by the differential of what's inside the function, which is minus 0.01. You always divide by the differential of what's inside the function. So this is what that side will give me when I integrate it. And I have my limits of v and 0. And here when I integrate 1 with respect to t, I'm just going to get t. So I have t, and I'll have my limits of t and 0. So when I continue here, this is going to give me, I'll take out the minus 0.01. So I have minus 1 over, in fact, if you divide that, if you work out what this is like minus 1 over 100th. So it's going to be minus 100. Okay, so just to confirm that, if you do 1 divided by, 0.01, whoops, 0.01, that gives you 100. So this is minus 100 times, and then you got here the ln of the modulus of 30 minus 0.01 v minus the ln of, now when you put 0 here, you get ln of 30. Okay, and that's equal to t minus 0, which is t. All right, so when you simplify this, okay, what we'll get is we're going to have, I can divide both sides by negative 100, and also I can combine these together. So I have ln of the modulus of 30 minus 0.01 v over 30 is equal to minus 100. Say minus 1 over 100 t. Okay, so now to make v the subject of this, I have to basically rewrite this in terms of index form. Okay, so this means log to the base e of something equals something. So it's e to the power of v. So it's going to be e to the power of this. So I have e to the power of negative 1 over 100 t is equal to all of this, which is 30 minus 0.01 v over 30. Okay, and now I can multiply both sides by 30. So I have 30 e to the power of minus 1 over 100 t is equal to 30 minus 0.01 v. And now I can make v the subject of this. Okay, so I'm going to take this to the other side and do that. Okay, so now I have to basically make v the subject. So I can, in this case, now what I can do is I can add 0.01 v to both sides, 0.01 v to both sides. And here I have take away this from both sides. So 30 minus 30 e to the power of minus 100th t. And this is, remember, the same as 1 over 100. So this is like v over 100 equals 30 minus 30 e to the power of minus, in fact, I can take out that 30 as common. So I can, that will be 30. And then I'll have 1 minus e to the power of minus 100th t. And I can multiply both sides by 100. So that's 3000 times 1 minus e to the power of minus 100th t. And there we have our answer. This is called the solution, the particular solution of this differential equation. And we found the value of the constant of integration automatically in this case. Right? Now, if you wanted to do it the other way, that's fine. In which case you would have basically, at this stage, you wouldn't have had any of these limits. You would have just integrated this, and you would have got exactly the same on this side, and then you'd have t plus c. And then you would substitute v equals 0, t equals 0 to find what c is, and then you would incorporate it into the answer. But I find this way easier to do. Okay, so here we have the answer. But then it says find the value of t when v equals 1000. So we can just simply replace, we want to find t when v equals, we want to find the value of t when, find the value of t when v equals 1000, right? We want to find the value of t when v equals 1000, we want to find what t is. Okay, so we can just replace this v with 1000. Okay, we can replace this v with 1000, so we have 1000 is equal to 3000 times 1 minus e to the power of minus 1 over 100 t. Divide both sides by 3000, you end up with 1/3 equals 1 minus e to the power of minus 100th t. I'm going to add this to both sides and subtract 1/3 from both sides. So I have e to the power of minus 100th t equals 2/3, because 1 minus 1/3 is 2/3. And I want to find what t is, so I can take the ln of both sides, because if I take log to the base e of both sides, it'll be left here with 1 over 100 t equals ln of 2/3. Okay, and now I can multiply both sides by minus 100. So I have t equals minus 100 times the ln of 2 over 3. Okay, and the question says find the value of t. Okay, so this is the value of t. Now, as it's something to do with time, what I'll do is I'll just write the answer to 3SF as well. Right, so I've got the exact value here, and I'll put minus 100 times the ln of 2/3. Okay, that give us 40.456. That's going to be t equals 40.4. Sorry, got the wrong thing, didn't I? 40.546. So therefore we can say the time is 40.5 and it was in minutes. Okay, that's the value of t. Right, so there's the answer to part B. Right, now if the question hadn't said solve the differential equation and find, if it just said find the value of t when v equals 1,000, then at this stage I could have put here v is 1,000, t is t, this is 0, and this is 0. And at this stage, instead of, what I would have done here is I would have put v is 1,000 in this place here. Okay, and then, when I rearrange it for t, when I rearrange it for t, okay, then I would get the answer almost directly, right? So once I had basically, if they didn't say solving the differential equation means they want an expression that looks like this, v in terms of t. Okay, so here there's two things to do: solve the differential equation and find the value of t when v equals 100. If the question was just this, find the value of t when v equals 1,000, I would have, as I said, at this stage, I would have put here v as 1,000 and then solved it, and when I find t, it would give me the answer. Okay, straight away. All right, I would have found the answer. And so this would have been 1,000 here. It would be 30 minus 0.01 times 1,000. Okay, which would have been 20, I think. So you'd have ln of 2/3. This would be ln of 20 over 30 equals minus 100. See, what would have happened here? You would have had minus 100 times, and that would have been the ln of, that would have been 30 minus, if you put 1,000 here, that's going to give you a 10, right? It's going to give you 10. So 30 minus 10 is 20. So you'll have ln of 20 minus ln of 30, okay, equals t, all right? And this would have given us the answer exactly that we're looking for here, I think. Yeah, minus 100 times ln of 2/3. Okay, so we would have had minus 100 times the ln of 2/3, because this becomes minus 100 times the ln of 20 over 30, which is 2/3, equals t. So we'd have got the answer almost immediately over here. Okay, but because the question says find or solve the differential equation, I'm trying to be safe, and I would write down the equation that links them together, okay, which is which we did over here already. Okay, so this is like answering the first part of the question. Okay, where did I write that? Yeah, so this is like the first part, solving the differential equation. Okay, that's like the first part of that answer, and then we put v equals 1,000 and then find the value of t. Okay, now it says obtain expression for v in terms of t and hence state what happens to v as t becomes large. Well, we've got that already. So v equals 3,000 times 1 minus e to the power of minus 1 over 100th, 1 over 100t. Okay, that's the expression of v in terms of t, and hence state what happens to v as t becomes large. So what we can do here, we have 3,000, and we have 1 minus, and we can write this as 1 over e to the power of 1 over 100th t. Okay, so we write that down like this. Now, what happens when t becomes large? Okay, so we can say as t approaches a very big number, infinity, then we can say that, you have 1 over e to the power of a very large number. Okay, 1 over e to the power of a very large number will approach 0, right? Because if you have something really large, okay, then this becomes close to 0, right? Because, if you make t really huge, you'll have e to the power of a really huge number. And 1 over something really huge is something that's close to 0. So this is going to approach 0. Therefore, v will approach 3,000, because you'll have v will approach 3,000 times 1 minus 0. So therefore, v will approach 3,000. Okay, so we can say as t becomes very large, as t becomes large, v, okay, approaches 3000. V approaches 3000. Okay, now what we can do here is we can also do a little check by using our calculator. I can put this equation into the calculator. So 3000, and I have 1 minus, I have e to the power of minus 1 over, and what I'm going to do is I'm going to put here a very large number. Like, let me put like so 1 over 100, and then I'm going to multiply that by a very large number. So times, and I'll put this, for example, let me put it as 100. Okay, oh, it says syntax error. Okay, let me put this as, what have I done wrong? Sorry, I've done something wrong here. There, that need a big bracket. Now, if I put that as 100, I get something which is 1,896. Okay, let me put it even bigger. Let's try and make it as big as we can. As you see, it ends up being 3,000. The bigger you make it, it's gonna basically show us 3,000. Okay, so that's where it will stop. Okay, so that will be basically what it will approach. Okay, it won't actually really approach that. Okay, but that's what the calculator will show us, because it's basically rounding it, because it's something very close to it. So basically, if you want to check you've done the right thing, you just set up your equation and put a really large number in the place of the variable, like the t here. I put a really large number in that place, okay, and then see what it gives you. And if you've done the right thing, it should give you the same number that you've given. You can use that as a little way to check that you've done the right thing in your reasoning. Okay, so there's the answer to part C of this question, and I think that completes this question. Yes, it does. Okay, so that's question number 10 done of this. As I said, for part B, just to be on the safe side, I actually solved the whole differential equation, and I ended up with this expression, and then I put 1,000 in it. As I said, if it just said find the value of t when v equals 1,000, what I would have done is I would have at this stage just put v as 1,000 in this limit, and then t you could find almost immediately then. Anyway, other questions from this particular paper can be found in the playlist that will be appearing at the top right of the screen at the end of this video. Other questions from differential equations from your P3 of Cambridge can be found in the playlist that will appear at the bottom right of the screen. Other questions from differential equations, which would be from P4 of Edexcel, which are very similar to these. You'll find lots of examples there in the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.